Hi, I'm Jan.
And I'm Cecilia.
We're here to talk to you about using Compose to build immersive experiences for Android XR and some of the exciting opportunities that lie at the intersection of AI and XR. Last December, at the XR Unlocked event, alongside Samsung and Qualcomm, we shared our vision for Android XR, Android's expansion into extended reality, bringing a whole spectrum of experiences from virtual reality to augmented reality to a variety of form factors, and laid the foundation with the developer preview for the Android XR SDK. Today, we're excited to revisit that foundation, covering a quick Android XR overview, and then building upon it by sharing some powerful features that leverage your existing Android and Jetpack Compose skills to build unique XR experiences. We'll also dive into how you can harness the power of AI directly within your immersive experiences, opening up a whole new dimension of possibilities. We'll bring this all together with a use case deep dive that showcases an app whose spatial UI is built with Jetpack Compose for XR, and then uses the Gemini 2.0 Flash and Imagen 3 models and Vertex AI for Firebase to do some virtual AI-powered home decorating. Then we'll wrap things up by sharing some resources and details on how you can get started building apps at the intersection of AI and extended reality. Cecilia, I'll hand it over to you to get us started with an overview of Android XR.
Thank you, Jan. History shows that it's within these type of intersections that innovation flourishes. So we are super excited to explore it with you. Android XR is the first platform built for the Gemini era, and we believe AI has the potential to revolutionize immersive experiences, making them more intelligent, personalized, intuitive, and agentic. Unlike traditional devices, XR devices have cameras and sensors that enable your apps to perceive the user and their environment naturally. This offers a unique opportunity for AI. Imagine applications that can understand your surroundings, respond to your natural language in a spatial context, and even generate content dynamically based on your environment and preferences. All of these built with Google's leading privacy standards by design. Let's start with an overview of Android XR. We believe extended reality, blending the physical and virtual worlds, will transform how we learn, connect, create, and play. Across a variety of use cases, we've been imagining a future where computing goes beyond the traditional rectangular screens, where content appears in physical space and rich applications truly understand your environment, extending reality in helpful and innovative ways. Combined with multimodal AI enabled directly into the system, Android XR opens up opportunities for you to build a wide range of experiences beyond what's possible on devices today. This new computing platform levels up experiences to help users navigate increasingly complex information in a more seamless, intuitive, and visual way, and to expand their world with endless possibilities across a spectrum of form factors. Starting from headsets with immersive experiences that surround you, and in the future, glasses that bring helpful, in-the-moment intelligent insights to users' day-to-day life. The first Android XR device will be a headset, Project Muham, from Samsung. Starting from its launch later this year, the ecosystem will expand further across headsets and glasses. Now, because Android XR is an extension of the Android ecosystem, users can install a wide range of apps on headsets from the Play Store. Many of you have already been optimizing your existing apps for large screens. To learn more about how these same optimizations will also help your apps look great on Android XR, be sure to check out this talk about adaptive app development. Let's take a minute to look at home space versus full space experiences on XR headsets. When you first put on a headset, you are welcomed by home space. Home space enables you to multitask multiple two-dimensional application windows side by side. For apps that have implemented XR differentiated features, you can transition the app into full space, where other apps are hidden, and the full space app comes into focus, filling the entire view around you. When you are ready to build XR differentiated apps, whether you are an Android developer using Android Studio or an immersive app developer using tools like Unity, we want to support you with the tools and technologies that you love and you're already building with today. Now I'm going to hand it back to Jan to explain more about the spatial UI capabilities and Jetpack Compose for XR.
Thanks, Cecilia. Jetpack Compose for XR is one of the libraries that make up the Jetpack XR SDK that we launched in developer preview last December. Our goal with this SDK was to provide a comprehensive and developer-friendly toolkit for building immersive experiences on Android XR headsets. Building user interfaces for XR comes with both opportunities and challenges. You have the opportunity to take advantage of the unconstrained boundaries and the ability to decompose your apps into multiple spatial panels with depth. While one of the key challenges in XR is creating user interfaces that feel natural and comfortable across different spatial contexts and device capabilities. Jetpack Compose for XR aims to make this easier, so you can declaratively build your spatial UI and layout using familiar Compose concepts such as rows and columns, adapted to suit the 3D space in which you're building. Because Compose for XR is working with spatial layouts and measurements that exist in 3 dimensions rather than the 2 dimensions you may be used to working with, there are some differences. Before we begin looking at the different spatial UI components that are available, it's important to understand the concept of a subspace and how that relates to spatial UI components. A subspace is a partition of 3D space within your app, where you can build 3D spatial layouts, place 3D models, or add depth to otherwise 2-dimensional content. A subspace and its contents are only rendered when spatialization is enabled. That is, only when your app is running on an XR-enabled device and in full space mode. When your app is in home space, or if it's running on a non-XR-enabled device, any code within that subspace is ignored. A subspace can be placed anywhere within your app's UI hierarchy. This can help you share things like existing app architecture between XR and other form factors without needing to re-architect your whole app. There are 2 categories of spatial UI components in Android XR: subspace composables, which can only be rendered within a subspace, and other spatialized components that do not have to be called within a subspace. One of the most foundational subspace composables is the spatial panel. You can think of a spatial panel as a plane in 3D space with a width and a height that acts as a surface or container in which content can be displayed. Spatial panels are the fundamental building blocks of Android XR apps, and they serve as containers for UI elements, interactive components, and immersive content. The spatial panel you see here is part of the Spatial AI Artwork app that we'll be referencing throughout the talk. Because a spatial panel is a subspace composable, you must call it within a subspace, as you can see illustrated in this example. Similar to how you use modifiers in Compose when you work with typical 2D composables, in XR you use a subspace modifier. While the concept is similar, they aren't interchangeable. When you work with a subspace composable, you use a subspace modifier. Some subspace modifiers will sound familiar, like padding, width, or height, while others are specific to XR, like movable or resizable. For this spatial panel, for instance, we're using a subspace modifier to change the size and behavior of the panel. If you're already familiar with Compose layout, such as building with rows and columns, then you'll find that laying out spatial UI with multiple spatial panels feels intuitive. Let's consider spatial row and spatial column and how they compare to their 2D counterparts, row and column. Row and column are used to place items horizontally or vertically on a screen, that is in 2D space. But in XR, we're able to build layouts and user interfaces in 3 dimensions. So these spatial row and spatial column composables for XR allow you to arrange elements linearly in 3D space along a specified axis. This makes it straightforward to create structured UI elements that maintain their relative positioning in the immersive environment. Now let's look at some of those other spatialized UI components that don't have to be placed within a subspace. These components consist of conventional 2D elements wrapped in a spatial container, and they can be placed anywhere in your app's UI hierarchy. When spatialization is not enabled, their spatialized features will be ignored and they'll fall back to their 2D counterparts. Orbiters are floating elements that typically contain controls the user can interact with. Orbiters are anchored to spatial panels or other entities such as spatial layouts. Orbiters can help declutter your app's UI and bring the user's attention to important controls such as a navigation rail, like you see in this example. By wrapping the navigation rail with an orbiter, it extracts it from your 2D layout. From here, you'd specify where and how you'd like to attach it to your app's panel. Adding elevation to spatial UI components can help get a user's attention, creates better hierarchy, and can improve legibility. Spatial dialogues and spatial pop-ups are two types of spatialized components that can help add depth and elevation to your app in meaningful ways. Spatial dialogues provide a way to present important information or prompts to the user in a focused and modal manner within the 3D environment. When spatialization is enabled, the dialogue will be placed higher in Z-depth to display an elevated dialogue in scrim panels. Spatial pop-ups behave similarly. And when you want even more fine-grained control over elevation in your UI, spatial elevation allows you to elevate any composable in your app to a higher Z-depth than the spatial panel. Up until now, we've been looking at how you can build and customize spatial UI and content for your apps using Jetpack Compose for XR. In addition, material design provides components and layouts that adapt for XR. You can adapt your current Material 3 implementation by adding the Enable XR Component Overrides wrapper. You can use this wrapper with components such as navigation rail or navigation bar, and those components will automatically adapt to an orbiter if the app is in full space. This is the approach we took for spatializing the UI for the spatial artwork example app. Using this wrapper results in the navigation rail moving into an orbiter when the app is in full space. Beyond UI, we're also focusing on making it easier for you to take advantage of the unique capabilities of XR headsets, to include content like stereoscopic video in your apps using Compose for XR. Because of the nature of XR headsets, where each eye has its own display, this form factor is particularly well suited for viewing stereoscopic content. Stereoscopic video, sometimes called 3D video, creates the illusion of 3D depth by showing slightly different images or streams of content to each eye. Much like what happens when we view things in the real world with our own eyes, these two different images or streams of content are combined by our brain to produce that single image with the perception of depth. Each image in a stereoscopic video is encoded as two eyes, either in a top-bottom format as shown here, or in a side-by-side format. We're excited to introduce Spatial External Surface, a new composable that can support rendering both stereoscopic and monoscopic, or regular, video formats. While some of the concepts we've covered may be new to you, remember that you don't have to start from scratch, and you don't need to spatialize every part of your app. You can build off your existing investments in large screen and adaptive development to expand your reach to XR devices and then implement whatever spatial UI features are most relevant and useful to your app. Now I'm going to turn it over to Cecilia to cover the power of AI in Android XR.
Amazing! We are excited to talk to you today about one of the ultimate frontiers in Android XR, the convergence of these two fast-moving waves, extended reality and artificial intelligence. So what are some of the use cases that are uniquely positioned to take advantage of AI in Android XR? First, creative content generation, the use case that we'll explore in this talk with Jan. AI can generate images and interactive elements on the fly and present this generated content in ways that take advantage of XR spatial capabilities, including spatial anchoring and infinite space. Second, context-aware interactions. AI can analyze the user's environment and provide relevant information or actions that enable the user to interact with the physical and digital content in novel ways. And third, one of my favorites, assistance and coaching, where conversational agents guide users, answer questions, and personalize immersive environments to tailor them to users' preferences, behaviors, and accessibility needs. This includes building real-time conversational multimodal agents able to process text, voice, image, and video, inputs and outputs. To match the different levels of your AI requirements, Gemini offers a wide range of constantly evolving foundational pre-trained models. You can mix these models however you like within your application, from the largest and most capable to the lighter and faster ones. You also have the ability to train and fine-tune your own custom models for tasks such as image recognition, natural language processing, and generative AI. You have different options to start leveraging the power of generative AI directly in your Android XR applications today. You can use Vertex AI in Firebase, which offers both an Android SDK in general availability and a new Unity SDK that is in public preview. You also have the option to use Vertex AI APIs directly if you prefer to implement your AI features on the backend. All of these options provide seamless ways to integrate Google's cutting-edge AI models and APIs into your XR applications. Over to you, Zhang, to bring this all together with an XR AI example.
Okay, let's dive into how all of this can work together to do some virtual AI-powered home decorating. Imagine an app on Android XR built with the Jetpack XR SDK that allows users to create personalized virtual spatial artwork using AI. Here's how it works. Wearing my Android XR headset in pass-through mode, I can look around my physical room. I have this blank wall here in the room that could really use some decoration. Using the camera app on my headset, I'm taking a few pictures of the room. Before I implemented this in the app, I drafted and validated the prompt in Vertex AI Studio using the Gemini 2.0 Flash model by supplying both a text prompt and an image of the room. Here's the prompt I decided on. Generate a list of the primary colors in the room that would be best to match with artwork. List only the color names and hex values in this format. Once I was satisfied with the prompt and responses, then I implemented this in my app using Vertex AI in Firebase. Based on this color analysis, then I used the Imagine 3 model to generate a few abstract images representing pieces of artwork that could coordinate nicely with the colors in my room. Again, I used Vertex AI Studio, but with the Imagine 3 model this time, to validate the prompt and see what kind of results would be generated. And then in the app, I implemented this prompt with Vertex AI in Firebase using the Imagine 3 model this time. By default, this would have returned a single image, but since we wanted 4 options to choose from, I used the generation config that you see here to specify the number of images that I wanted in the response. Now let's take a look. I can see all 4 images that were generated for me, and when I decide on one that I like, I can select the painting icon to get a movable painting that I can attach to the wall where I want it. Attaching a panel or other entity to a wall like this is called anchoring. In this case, you can see there's a little lock icon. That's going to persist or store the information about where this painting is anchored, in effect remembering where I've placed it. Now I can select my favorite piece of generated artwork and anchor it to a wall in my physical environment while the app remains in pass-through mode. You can use the AR Core for Jetpack XR library, which is part of the Jetpack XR SDK, to implement this kind of anchoring behavior. You can learn about anchoring in depth in the talk on building differentiated apps for Android XR with 3D content. My teammate Amy got in on the virtual decorating fun too. Here she is trying it out. I really love the color combinations and the artwork that were generated for this room. This app just scratches the surface of what you can build when you combine the expressive UI capabilities of Compose for XR, the spatial awareness of the Android XR platform, and the creative potential of these AI models through Vertex AI and Firebase. Think about the possibilities. Personalized virtual home decor, context-aware storytelling, immersive educational experiences that adapt to the learning environment. The potential is truly limitless. We are incredibly excited about the future of Android XR, and we can't wait to see what you, our talented developer community, will create with these new tools. If you haven't already, we recommend you check out the announcement blog post and watch some of the recordings from our developer preview launch. Check out our developer documentation for the Android XR SDK, where you can also find instructions for installing the Android XR emulator, samples for Android XR, and documentation and samples for Vertex AI and Firebase to help you bring those AI use cases to life in XR. Download Android Studio with the Android XR emulator and get started building for XR today. The advancements in the Android XR SDK combined with the power of AI are opening up a new era of immersive computing. Your creativity and innovation will drive this future, and we're here to provide you with the best possible tools and resources. Thank you for joining this session.